And this is Ramakrishna, and I am going to continue with the theory part. In the theory part, it includes the investigation on Cripping waves, and this investigation on Cripping waves will continue for the different types of regions. And the third part is the placement of the receiver, which is one of the major problems in our project. First of all, investigation of Cripping waves. The studies have been done in the electromagnetic scattering situation on a convex surface. First of all, before we are going to investigate on Cripping waves, we have chosen the studies on the electromagnetic waves on a convex surface scattering. And first of all, here from this diagram, we can see there are some reflected waves and there are some diffracted waves. When a transmitter transmits some electromagnetic waves, which coincides the cylinder. When it coincides the cylinder, we can able to see some of them are reflected and some of them are diffracted here. But basically, from this theory, we just want to know what are Cripping waves. But many people knows Cripping wave can creeps, but most of them might have not known where it creeps and how it creeps. Technically, Cripping waves are the diffracted waves which get diffracts when the electromagnetic wave coincides with the convex surface or the cylinder surface, and it will diffract onto the surface, and then it will behave like it will be creeping like onto the surface, and these are called the Cripping waves. So basically, technically, we have to say these are diffracted waves. Diffracted waves means it gets some bending when it coincides with the cylinder. And the third one is, once we came to know what are the Cripping waves, we try to extend our study from the convex surface to the cylinder surface, since convex surface is the half part of the cylinder surface. So here, the studies have been done in case of cylinder, and this cylinder is coated with the dielectric material, and during our investigation, this cylinder is coated with the dielectric material, and in our own project, the cylinder is not coated. So during our investigation, we find out that the behavior of the Cripping waves will be more or less similar to the coated and uncoated one. And this will be very well described in the U2D solution, and this is useful for the electromagnetic scattering, to solve the electromagnetic scattering problems. Basically, it is the high frequency method, and which is useful when we are working with the high frequencies, which can be useful. This U2D solution is useful onto the convex surface or onto the cylinder surface. So let's go for the second part, and here is the types of regions. So different types of region. Before we are going to know about Cripping wave behaviors, we have to place them in different types of regions. And here there are two types of regions. One is called lit region, and another one is the shadow region. First one is the lit region. The region above the upper shadow boundary and the region below the lower shadow boundary. We can refer it as the lit region. The region above and the below. And next, the second one is the shadow region. The only region behind the cylinder. Only region behind the cylinder is referred as the shadow boundary. And these terms will be useful in the third part to place a receiver. Exactly. So here, placement of the receiver, as I said before, it is a major problem in our project. And this is mainly defined from the 10 lambda criterion. Actually, the studies have been done in the time domain analysis of the Cripping wave. It is very well described, and the 10 lambda criterion is very well described in this paper. So, first of all, I would like to say why we choose this criterion. This criterion is directly related with the radius, and this is one of our goal to achieve in our project. So here it is directly related in different cases. One is when the radius is greater than 10 lambda, and other one is when the greater is smaller than 10 lambda. Here the lambda is just a wavelength corresponding to the frequency of the instant wave. When we transmit some wave, it is just corresponding to that frequency, is lambda.